The first question, two unbiased coins are tossed. What is the probability of getting both heads? First we find out the sample space. The first one is both can be head. Second case may be first one is head, second one is tail. Then tail head, then both are tail. Therefore, how many elements are there? 4 elements. And how many favorable outcomes? Only one. That means we want both the heads. Therefore, only one favorable outcomes. Therefore, our probability is 1 is the favorable outcomes divided by total number of elements in the sample space. Therefore, 0.25. Therefore, option B is the correct option. The next problem is an unbiased die is rolled. What is the probability of getting the prime numbers? Here also, what is the sample space? Find the sample space. Sample space. If an unbiased die is rolled, the sample space are 1, 2, 3, 4, 5 and 6. And what are the favorable outcomes? Favorable outcomes is what? Prime numbers. Therefore 2, 3 and 5. Therefore the probability is total number of favorable outcomes is 3 divided by total number of elements in the sample space. Therefore it is 0.5. Therefore our option B is the correct option. Three unbiased coins are tossed simultaneously. What is the probability of getting exactly 2 heads? So first find the sample space. What are the possible cases? Head, 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 then head, head, tail, then head, tail, head, then head, tail, tail, then tail, head, head, then tail, head, tail, 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 head, and tail, tail, tail. See, this can be done in a simplified way. If you know the binaries, therefore head can be considered as a 0, tail can be considered as a 1. Therefore first element is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Therefore total 8 entries, therefore 8 elements are there. What are the favorable case? For whatever the favorable outcomes, we should get exactly 2 heads. Therefore you can look at that. This the first is, I underline, this is the first cases, this is the second case, this is the third case, and no more. Therefore our probability is total number of favorable outcomes and divided by total number of elements in the sample space, and that is equal to 0.375. Therefore option A is the correct option. Next question is, two unbiased dice are rolled simultaneously. What is the probability that sum of the numbers appearing to be 9? First we go to sample space. if how many elements will be there in the sample space, therefore sample space. Therefore you can see the first dice is 1, second one is also 1. We'll keep the 1 constant, therefore now a second die will change, therefore 1, 1,3, therefore we'll get. Next we'll start from the 2, 2, 1, 2, 2 and 2, 3. In this way we'll get 6. In this way we'll get total number of elements in the sample space will be is equal to 36. Now come to this, our favorable outcomes. Favorable outcomes. How many? We should get that the sum should be 9. Therefore, 1 is 3,6. Then 4,5. The first dice it is 4. Second dice it is 5. Therefore, 5, 4. Then 6, 3. Therefore, you can see there are total favorable outcomes are 4. Therefore, you can say the probability is, our required probability is total favorable outcomes divided by total number of elements in the sample space. Therefore, 1 by 9. This is 1 by 9 is our required probability. Therefore, option A is the correct option. The next problem is 2 unbiased dice are rolled simultaneously. What is the probability that sum of the numbers appear to be 6 or 9? The first we can find the sample space. The sample space for all possible cases. Therefore, as we found earlier, 1, 1, 1, 2, and in this way, in the sample space, total number of entries will be 36. Now we'll take A is an event where the sum is 6. How many possible entries will be there? Sum is 6 means 1, 5, then 2, 4, then 3, 3, then 4, 2, then 5, 1. These are all possible entries. And how many are there? Total are there is 5 are there. And another event B where the sum is 9. Then what are the possible entries? You can see it is possible 3, 6, then 4, 5, then 5, 4, then 6, 3. These are the possible entries where the summation is 9. And how many elements are there? 4 elements. Now, what is the probability? What is the PA? Probability of A. There are total 5 favorable outcomes and total in the sample space there are 36. Therefore, this is the probability of A. What is PB? PB is equal to 4 by 36. Now, any one of the event happen, that means probability of A union B. And what is this? PA plus PB minus intersection of A and B, and that intersection is of, you can see it is 0. because there is no common elements. Now you substitute that. PA equal to how much? We got 5 by 36. That is 4 by 36. That is 9 by 36. And that is equal to 1 by 4. And that is equal to 0.25. That is our required probability. And therefore, you can look at that. The option C is the correct option here. The next question is 20 cards are marked from 1 to 20. One card is drawn from the pack of cards randomly. What is the probability that the card is divisible by 3 or divisible by 5? The first we find the sample space. What is the sample space in here? The sample space are 1 to 20. These are all possible cases. Therefore, total entry 20 elements are there. Now, let us consider an event A where it is divisible by 3. So, what are the entries? 3, 6, 9, 12, 15 and 18. How many elements are there? You can see there are 6 elements are there. Next, another event you take where the card is divisible by 5. What are the elements? 5, 10, 15 and 20. How many elements? 4. Now one thing you can see here, in the event A, the 15 and event B, that 15 are common. That we'll consider now. Now you see, we want to, now what is the probability of P? What is the probability of A? A is 6 by 20. And what is the probability of B? B is 4 by 20. Now any event, any one of them, at least one of them to be happen, that is the probability we are going to find out. That is P A union B. That is equal to, PA plus PB minus P of intersection of A intersection B. What is the PA we found out just now? We found out PA equal to 6 by 20. PB equal to 4 by 20. And how many common elements? One common element. Therefore, 1 by 20 intersection. Therefore, we can see that is equal to 9 by 20. That is equal to 0.45. And that is our probability. And therefore, the option D is the correct option. You can see the option D is the correct option. Next question is, 2 unbiased dice A and B are rolled simultaneously. What is the probability of getting 5 on A and 4 on B? Therefore, we have already know that the sample space for 2 dice to be rolled are 1, 1. In this way, we know there are total 36 possible cases and favorable outcomes. Favorable outcomes is 5 on A and 4 on B. That is only one possible favorable outcomes. Therefore, our required probability is 1 by 36. Therefore, the option D is the correct option. The next question is, a bag contains 3 red balls, 4 white balls and 5 black balls. A ball is drawn at random from the bag. What is the probability of drawing a white ball or black ball? Now here you can see the sample space. The sample space, how many elements are there? In the sample space, there will be 12 elements. It can be any ball, 3 red balls, 4 white balls, 5 black balls. Any of the balls can be drawn. Favorable events. How many favorable outcomes? Favorable outcomes, how many elements should be there in there? Favorable outcomes are either white balls or black ball. How many white balls are there? 4 white balls and 5 black balls. Therefore, total element in the favorable outcome should be 9. Therefore, our required probability will be total favorable outcomes divided by total elements in the sample space. Therefore, 3 by 4 and 0.75. Therefore, your option C is correct. The next problem is, two machines A and B produce balls of 25% and 75% respectively. 2% and 4% of the balls are defective produced by A and B respectively. What is the probability that the bolt is defective if one bolt is picked up at random? In this problem, let us consider that total number of balls produced by both together A and B is X. Therefore, total balls produced by both together A and B is equal to X. Then how many balls are produced by A? 25%. 25% X. And out of that, how many are defective? 2% are defective. Therefore, 2% are defective. Therefore, if you multiply that, you will get 0.5 divided by 100 into X are the defective balls produced by A. Similarly, B. How many balls are produced by B? 75%. Therefore, 75% into X. And out of that, how many are defective? 4% are defective. Therefore, 3 by 100 into X are the defective. Now, together, how many defective balls are produced? 3.5x divided by 100. Together A and B. Therefore, you can see the sample space. Sample space of this problem is all the balls together produced by A and B. How many? Is X. Favorable events. Favorable here is defective. Favorable outcomes are the defective. What are the, how many are defective? 3.5 divided by 100 into X. These are the defective. These are the, this number of elements will be in there. Will be in there in the favorable outcomes. Therefore, what is the probability? Therefore, the probability will be favorable is 3.5 divided by 100x divided by x. Therefore, is equal to 0.035. Therefore, the option A is correct option. Therefore, you can see the option A is the correct option. The next problem is, a bag contains 10 red balls, 6 white balls, 2 balls are drawn one after another without replacement. What is the probability that both the balls are red? In this problem, or required probability, to find the required probability, you see the first one ball to be drawn. How many red balls are there? 10 red balls are there. How many total number of balls? 16. Therefore, this is the probability of drawing the first ball. And after drawing the first ball, how many balls remains? Because replacement has been not done. 9 red balls. Therefore, 9. And how many total? 15. Therefore, if this is our required probability, therefore, if you simplify, this is 2, this is 3, and this is 3, and this is 8. Therefore, 3 by 8. And therefore, the answer is 0.375, 3 by 8. Therefore, your option C is correct. Alternately, you can do it in the other way, alternately. Alternate. The probability is equal to the two balls, red balls can be drawn in the 10C2 and from 16C2, total way of, and this if you simplify, that is 45, and this is 120 and gives 375. Therefore, both the answers are correct, but you can do in one of the way wherever you like.